I make an appeal. Please like and share my videos and subscribe my channel if you have not already subscribed. Thank you. In the JEE Main exam held in January 2024 session, about 10 questions, 10 numerical value questions were asked from the topic definite integral from the chapter Integral Calculus. We have already discussed the first 4 questions. We now discuss the next 6 questions, that is question number 5 to 10 in this video. This question has appeared in the JEE Main exam held on 31st January 2024 in the first shift. Let f be a function from the set of real numbers to itself defined by f of x is equal to 4 power x by 4 power x plus 2, and m is given to be the definite integral f of a to f of 1 minus a of the integrand is x times sine to the power of 4 in brackets x times 1 minus x with respect to x, and n is the definite integral from f of a to f of 1 minus a of sine to the power of 4 of in brackets x into 1 minus x dx, where a is not equal to 1 by 2. Right. If alpha m is equal to beta n, m is above given and n is above given, and if alpha m is equal to beta n, alpha beta belongs to natural numbers, then the least value of alpha square plus beta square is equal to. Right. Let's now discuss the solution of the problem in detail. Now, we will see first of all what is f of a plus f of 1 minus a. So what are we trying? We are trying to apply a rule called, a property called King's property. For that we need the lower limit plus upper limit minus x. X is to be replaced by the lower limit plus upper limit minus x. Then you get the same integral, right? So that's the King's property. For that, f of a plus f of 1 minus a, f of a is here, f of 1 minus a is here, and simplified, we get that it is equal to 1. So f of a plus f of 1 minus a is 1. Now replacing, so f of a plus f of 1 minus a is 1. Now m is the integral f of a to f of 1 minus a into x sine to the power of 4 of in brackets x into 1 minus x with respect to x. So we apply this King's property. So replacing x by f of a plus f of 1 minus a minus x, that is 1 minus x. Replace x by 1 minus x, then 1 minus x is to be replaced by x. Right. Get into the problem. Apply f of a, integral f of a to f of 1 minus a. Apply the King's property. Wherever there is x, you write 1 minus x, and wherever there is 1 minus x, you write x. Then you will get the same, this function. So now separate integral f of a to f of 1 minus a of 1 into sine to the power of 4 into x into 1 minus x dx, minus integral f of a to f of 1 minus a x times sine to the power of 4 x into 1 minus x dx. The first one is precisely n, The second one is m. So thus we got n minus m. N minus. This first one is n. It's here. And this second one is m only. So m is equal to n minus m. That will imply 2m is equal to n. Now what is given? Given to you alpha m is equal to beta n, where alpha beta belongs to n. What is to be found? The least value of alpha square plus beta square. So the least value will be obtained if you take the GCD of alpha plus 1, alpha and beta is 1. So if alpha comma beta is 1, that is the GCD of alpha comma beta is 1, then we get the least value of alpha square plus beta square, and that is alpha is 2 and beta is 1. So alpha is 2, beta is 1, and the value of alpha square plus beta square is 2 square plus 1 square, that is equal to 5. So that is the detailed discussion of the solution of this problem, and the answer to this question is 5. Right. Let's now move to the next question. Right. This question has appeared in the JEE Main exam held on 31st January 2024 in the first shift. The given question is, let S is equal to the open interval -1 to infinity, and f is a real valued function defined as f of x is equal to integral, definite integral -1 to x, the product of the factors. The factors are e power t minus 1 to the power of 11 multiplied by 2t minus 1 to the power of 5 multiplied by t minus 2 to the power of 7 multiplied by t minus 3 to the power of 12 multiplied by 2t minus 10 to the power of 61, and with respect to t. Let P be the sum of the squares of the values of x where f of x attains local maxima on S, and Q is the sum of the values of x where f of x attains local minima on S. Then required to find the value of P square plus 2Q, and we are given a function from the open interval -1 to infinity into real numbers defined like this as a definite integral, and P is given to be the sum of the squares of the values of x where f of x attains local maxima on S, and Q is the sum of the values of x where f of x attains local minima on S, required to find the value of P square plus 2Q. Let's now discuss the solution of the problem in the next slide. Let us now discuss the solution of the problem. We have f prime x is equal to e to the power of x minus 1 to the power of 11 into 2 to the power of 5 into x minus 1 by 2 to the power of 5 into x minus 2 to the power of 7 into x minus 3 to the power of 12 into 2 to the power of 61 into x minus 5 to the power of 61. This is what we have brought forward from the last slide. For critical points, we equate the first derivative is equal to 0. We got these critical points. Now, what is the behavior of f prime x while crossing these critical points? Right. So let's now take, this is the real axis, and then mark the critical points. 0, 1 by 2, 2, 3, and 5. Right. If you take a x greater than 5, if you take an x greater than 5, x minus 5 is positive and all the other people are positive. So we get positive sign here. Right. We got positive, and now we talk about a value between 3 and 5. So a value bigger than 3 but less than 5, then it is x minus 3 is positive, positive to the power of 12 is positive, and this is a negative, negative to the power of 61, right? So it's positive, it is a negative, so this is negative, right? Up to this it is a negative we got, but suppose you take a point greater than 2 but less than 3. Let us say 2.5 we take. So 2.5 minus 5, negative, negative to the power of 61 is negative. Here also you get negative, but negative to the power of 12, 12 is even, therefore you get positive, and positive into negative, negative will get, and the remaining are all positive. And like that you go on doing it, right? Up to this we got. So this is negative. That means up to this is negative. If you take an x to the left of 0, let us say some negative number, then e to the power of x minus 1 is negative. Be careful. E to the power of x minus 1 is negative, and we have already, up to this it is negative. Negative into negative, positive will get. Right. That's what the signs of f prime x. Now note that f prime x changes sign from positive to negative as x crosses through 0 and 2. X crosses through 0, x crosses through 2. This will tell you 0 and 2 are the points of local maxima, and secondly, f prime x changes sign from negative to positive while crossing x is equal to 1 by 2, and while crossing x is equal to 5. Therefore, 1 by 2 and 5 are the points of local minima. Now what is P? P is the sum of the squares of the values of x where f of x attains local maxima on S. Local maxima is attained at 0 and 2. The squares of it, 0 square plus 2 square, that is equal to 4. And Q is the sum of the values of x where f of x attains the local minima on S. The local minima is attained at 1 by 2 and 5. The sum of the values is 1 by 2 plus 5, that is 11 by 2. What is wanted is P square plus 2Q. P square is 4 square, that is 16, plus 2Q is 2 into 11 by 2 is 11, that is 16 plus 11, that is 27. That's our answer. That is the detailed discussion of the solution of this problem. The answer to this question is 27. Let's now move to the next question. This question has appeared in the JEE Main exam held on 31st January 2024 in the first shift. If the integral 525 times integral 0 to pi by 2 sine 2x cos to the power of 11 by 2 x into, in brackets, 1 plus cos to the power of 5 by 2 x whole power 1 by 2 dx is equal to n root 2 minus 64, then what is the value of n? That is the question to us. So that means the question is just to evaluate this integral. For that, we take 525 into 0 to pi by 2 sine 2x cos to the power of 11 by 2 x into 1 plus cos to the power of 5 by 2 x to the power of 1 by 2 dx. Right. For sine 2x, we have written 2 sine x. Then you will get 2 sin x cos x and the remaining thing as it is. Now this 2 we have taken out and multiplied, and that will become 1050. So that will 1050 integral 0 to pi sin x into cos to the power of 13 by 2x. Why? Because cos x multiplied by cos to the power of 11 by 2x. So when multiplied, this will be same, and the remaining things as it is. Now we want to put 1 plus cos 5 by 2x as some t. When you differentiate, you will get cos to the power of 3 by 2, 5 by 2 multiplied by cos to the power of 3 by 2. So what we have written is 1 plus cos to the power of 5 by 2x is equal to t. That is 5 by 2 into cos to the power of 3 by 2x into cos x derivative with respect to x minus sin x with respect to x is equal to dt. Substitute. So substitute. That will be cos to the power of, then what will be the cos to the power of 3 by 2x into sin x dx? That will be minus 2 by 5 dt. And the limits will change. How this will change? As x varies from 0 to pi by 2, t will change from 2 to 1. 2 to 1. And that is equal to 10 times 1050 into integral 0 to pi by 2. Now, here we have written cos to the power of 5x into 1 plus cos to the power of 5 by 2x whole to the power of 1 by 2 into cos to the power of 3 by 2x sin x dx. Now, we have adjusted the terms. So, you will get this is equal to 1050 integral become 2 to 1 cos to the power of 5x. Cos to the power of 5 by 2x is equal to t. Cos to the power of 5 by 2x is equal to t minus 1. Cos to the power of 5 is t minus 1 whole square into this is t to the power of 1 by 2. And cos to the power of 3 by 2x sin x dx is minus 2 by 5 dt. Now the question is the adjustment is all right for you? Is the adjustment is all right for you? Right? Cos to the power of 5x into cos to the power of 3 by 2x is 5 plus 3 by 2, that is 13 by 2. That is split as these two terms because of the presence of the coefficient of dx. Right. So we got this one, and that is 420 into t minus 1 whole square is t square minus 2t plus 1 multiplied by t to the power of 1 by 2. That will be t square into t to the power of 1 by 2, t to the power of 5 by 2 minus 2t to the power of 3 by 2 plus t to the power of 1 by 2 after multiplying by t to the power of 1 by 2. We continue in the next slide. Right. This is what we have. Just integrate between the limits 1 to 2. So the integral of t to the power of 5 by 2 is 2 by 7 t to the power of 7 by 2 minus 2 into 2 by 5 t to the power of 5 by 2 plus 2 by 3 t to the power of 3 by 2 between the limits 1 to 2. So we have taken out a root to t common. So root t is taken common and written. And now take the upper limit. For this upper limit, this is the value. For the lower limit, this is the value. Right. Simplify. 420 into root 2 into this minus this. Further simplification, 420 into root 2 into this bracket, we evaluated, we got 44 by 105 minus this bracket when evaluated 16 by 105. So 105 is common in the denominator and cancel with 4 times. So you will get 4 times root 2 multiplied by 44 minus 16, that is 176 times root 2 minus 64. But this is given to be n root 2 minus 64. So comparing we get n is equal to 176. The answer to this question is 176, and that is the detailed discussion of the solution of this problem. Let's now move to the next question. This question has appeared in the 31st January 2024 in the first shift. The given question is mod of 120 by pi cube integral 0 to pi x square sin x cos x by, in the denominator, sin to the power of 4x plus cos to the power of 4x with respect to x is equal to. So we have to evaluate the integral. So let I be equal to the integral 0 to pi x square sin x cos x by sin to the power of 4x plus cos to the power of 4x dx. Call it as 1. Call it as 1. We want to apply the King's property. So for the King's property, replace x by 0 lower limit plus pi the upper limit minus x, that is pi minus x. So you will get I is equal to integral 0 to pi, wherever there is x you write pi minus x, right? So pi minus x we have written. Now cos sin of pi minus x, sin of pi minus x is sin x, cos of pi minus x is minus cos x. So that will be equal to integral 0 to pi minus pi minus x whole square into sin x into cos x. This minus is because of cos of pi minus x. So you got the second equation. Now add 1 and 2. Then you will get I plus I 2i integral 0 to pi, and this is x square. Here minus pi minus x whole square in bracket, and the remaining is as it is. Right. Now when you expand x square minus pi minus x whole square, this will be minus pi square plus 2 pi x minus x square. Minus x square plus x square cancels. You will get integral 0 to pi 2x pi minus pi square, and the remaining thing as it is. From this 2x pi minus pi square, we have taken out a pi common. Then you will get 0 to pi 2x minus pi into the remaining thing as it is. Right. So we apply another property. The another property is integral 0 to 2a f of x dx will be 2 times integral 0 to a of the 2a of f of x dx if f of 2a minus x is f of x. And in our case 2a is pi, a will be pi by 2. So we have to see f of pi minus x. So what is f of x? F of x is this. So f of x is 2x minus pi sin x cos x by sin to the power of 4x cos to the power of 4x. Then we will see what will be f of pi minus x. So wherever there is x, you just simply substitute pi minus x. And simplify, you will get this as this one. Minus pi minus 2x sin x cos x by sin to the power of 4x plus cos to the power of 4x. But we have 2x minus pi. This minus, the answer we got. When you take minus inside, 2x minus pi, this is precisely your f of x. Then the integral 0 to pi f of x, applying this, will be 2 times integral 0 to pi by 2 f of x. Then this will be pi into 2 times the integral 0 to pi by 2 of this. And 2i is equal to pi into 2 times the integral. So 2 cancels. You will get I is equal to pi times integral 0 to pi by 2, 2x minus pi into sin x cos x by sin to the power of 4x plus cos to the power of 4x dx. Let's call this as 3. We continue in the next slide. We have the brought forward here. Agreed. We want to again apply the King's property. That is, wherever there is x, you write pi by 2 minus x. Wherever there is x, you write pi by 2 minus x. X is not here. And simplify. You will get I is equal to pi times integral 0 to pi by 2 minus 2x sin x cos x by sin to the power of 4x plus cos to the power of 4x dx. X is not here. Please note down. It's a mistake. Agreed. Agreed. Now, if you add these two, 2x and minus 2x will cancel and you will get a minus pi here. So, 3 plus 2i is equal to pi into integral 0 to pi by 2 minus pi. The remaining thing is as it is. As it is. Agreed. So, this is I is equal to minus pi will come out, pi into minus pi square by 2, because 2i is this, I will be minus pi square by 2, integral 0 to pi by 2 sin x cos x by sin to the power of 4x plus cos to the power of 4x dx. Divide both numerator and denominator by cos to the power of 4x. Then you will get tan x secant square x by tan to the power of 4x plus 1. If you substitute for tan square x is equal to tan square x is equal to t square, t is equal to tan square x, substitute t is equal to tan square x, then you will get t square plus 1 in the t is equal to tan square x, substitute, it will be t square plus 1 and the dx will be 2 tan x secant square x, that is the derivative of tan square x is 2 tan x secant square x, and here we have tan x secant square x by this. So if you integrate this one, it will be 1 by 2 into tan inverse of tan square x, tan inverse of t, and this 1 by 2 is because of 2 is missing here in the derivative. So it will to be evaluated between 0 to pi by 2, and this will be minus pi square by 4 into tan inverse of tan square pi by 2, that is infinity, tan inverse infinity, minus for the lower limits tan inverse 0. For tan inverse infinity, it is pi by 2, tan inverse 0 minus 0, we get minus pi cube by 8. Let's go back. I is equal to minus pi cube by 8. Let's go back to the question, that is mod of 120 by pi cube integral 0 to pi x square sin x cos x by sin to the power of 4x plus cos to the power of 4x dx is mod of 120 by pi cube into I. I we have evaluated, that we got it as minus pi cube by 8. Pi cube cancels. 8 15s are 120 and mod of minus 150 will be plus 15. 120 by 8 is 15 minus 15, mod of minus 15 is plus 15. The answer to this question is 15. That is the detailed discussion of the solution of this problem, and it takes a little bit of time in the examination. We move to the next question. This question has appeared on 1st February 2024 in the first session examination. The given question is integral minus pi by 2 plus pi by 2 8 root 2 multiplied by cos x in the numerator by 1 plus e to the power of sin x multiplied by 1 plus sin to the power of 4x with respect to x, that is given to be alpha pi plus beta times log of 3 plus 2 root 2 to the base e, where alpha beta are integers then alpha square plus beta square equals. So we have to evaluate this integral. So we call that integral as I, called as the equation 1. Now we want to again apply the King's property, and we replace x by minus pi by 2 plus pi by 2 minus x, that is x by minus x by King's property. Then you will get I is equal to, wherever there is x you write minus x, cos of minus x, 1 plus e to the power of sine of minus x, and 1 plus sine of minus x whole to the power of 4. Sine of minus x is minus sine x, cos of minus x is just cos x. So that will become 8 root 2 cos x, but here 1 plus e to the power of minus sine x, and it is a positive power, so it will be 1 plus sine to the power of 4x. You get this one. For e to the power of minus sine x, we write 1 by e to the power of sine x, take the LCM, then we get it as integral minus pi by 2 plus pi by 2, 8 root 2 cos x into e power sine x, because of 1 by e to the power of sine x, that comes to the numerator, and this will be 1 plus e to the power of sine x into 1 plus sine to the power of 4x dx, adding 1 and 2. So we will get 2i is equal to 8 root 2 is taken out, integral minus pi by 2 plus pi by 2, cos x by 1 plus sine power 4x is common, and 1 by e to the power of sine x is also common, and in the numerator you will get 1 plus e to the power of sine x. From here it is 1, from here e to the power of sine x will come from the numerator. This will cancel, 1 plus e to the power of sine x will cancel. Then you are left with 2i is 8 root 2, so I will be 4 root 2 times of integral minus pi by 2 to pi, after cancellation, cos x by 1 plus sine to the power of 4x dx. We continue for the further evaluation. Right, that's what we have, that is the brought forward we have, and now this is 4 root 2 times 2 times integral 0 to pi by 2 cos x by 1 plus sine to the power of 4x dx. Why? It is the integrand is an even function. If you replace x by minus x, it remains the same. That is why the 2 times of integral 0 to pi by 2 has come. Agreed. Minus pi by 2 plus pi by 2 has become 2 times 0 to pi by 2. And that will be, and now sin x is equal to t, and differentiate cos x dx is equal to dt, and 0 to pi by 2, the limits will change to t is equal to 0 to 1. That will be equal to 8 root 2 integral 0 to 1, cos x dx is dt, by this is 1 plus t to the power of 4. Yes. Divide both numerator and denominator by t square. Then you will get integral 0 to 1, 1 by t square plus 1 by t square. Right. This we have written it as, this is 2 by t square, and this is 4 root 2 we made it. That 2 by t square we have written as 1 plus t square minus of 1 minus 1 by t square. That will be 2 by t square, separated. Then we have written in the denominator for t square plus 1 by t square, we have written t minus 1 by t whole square plus 2. That is the adjustment we have made. Why? Because the derivative of t minus 1 by t is 1 plus 1 by t square. In the second one, we have written t square plus 1 by t square as t plus 1 by t whole square minus 2. This is how we have written. This is because the numerator is 1 minus 1 by t square, which is the derivative of t plus 1 by t with respect to t. Agreed. This is equal to 4 root 2 into I1 minus I2, where I1 is the integral of the first one, the I2 is the integral of the second one. We evaluate these two in the next slide. Yes, we have, and we got I1 where I1 is the first one, integral 0 to 1 plus 1 by t square by t minus 1 by t whole square plus 2 with respect to t, and I2 is the next one. Right. First we evaluate I1. Put to t minus 1 by t as u, the derivative 1 plus 1 by t square with respect to t will be du. The limits will vary from minus infinity to 0. Right. I1 will be integral minus infinity to 0, 1 by du by u square plus 2. And 1 by u square plus 2, you see it as u square plus root 2 whole square. And remember, the integral of 1 by x square plus a square with respect to x is 1 by a into tan inverse x by a. This will be 1 by root 2 into tan inverse u by root 2. The integral to be evaluated from minus infinity to 0. When you evaluate for the upper limit, for the lower limit, and tan inverse 0 is 0, and minus tan inverse of minus infinity is minus of minus pi by 2, that is pi by 2, that is pi by 2 root 2, that is I1 is evaluated. We go to I2. Similarly, we substitute for t plus 1 by t v, and after differentiation we'll get 1 minus 1 by t square in brackets dt is equal to dv, and the limits will vary from infinity to t. I2 is integral infinity to t 1 by v square minus 2 dv. This you can see it as 1 by v square minus root 2 whole square with respect to v. Remember, integral 1 by x square minus a square is equal to 1 by 2a into logarithm of x minus a by x plus a. So 1 by 2 root 2 into ln of v minus root 2 by v plus root 2. Right. So that will be 1 by 2 root 2 into ln of 2 minus root 2 by 2 plus root 2 minus 0. So thus we got 1 by 2 root 2 into ln of 2 minus root 2 by 2 plus root 2. Here you may be surprised to say why we got 1 by 2 root 2. You think this is 1 by root 2. No, 1 by 2a. 1 by 2a. 1 by 2. A is a root 2. That is the reason. That's the reason. Now we go and evaluate 4 root 2 into I1 minus I2. Right. So we have this, and we got the values of I1 and I2. Simply substitute here. I is equal to 4 root 2 times I1 is pi by 2 root 2 minus I2 is 1 by 2 root 2 into ln of 2 minus root 2 by 2 plus root 2. This minus we have taken inside. Then this a by b will become b by a. And that will be equal to, minus has become plus 4 root 2 by 2 root 2 is 2. 2 pi. 4 root 2 by 2 root 2 is 2. This minus has become plus 2, and this is reverted 2 plus ln of 2 plus root 2 by 2 minus root 2. Now rationalize the denominator. Then simplify. You will get 2 pi plus 2 ln of, after simplification you get 3 plus 2 root 2, but it is given to be alpha pi plus beta times log of 3 plus 2 root 2 to the base e. It is given. comparing the coefficients, so comparing the corresponding terms, we'll get alpha is equal to 2, beta is equal to 2. But what is to be obtained? We have to obtain the alpha square plus beta square. That is 2 square plus 2 square. That is 8. The answer to this question is 8, and that is the detailed discussion of the solution of this problem. Let's now move to the next question. This question has appeared in the JEE Main exam held on 1st February 2024 in the second shift. Let f be a function from the open interval 0 to infinity to the set of real numbers, and capital F of x is defined as integral 0 to x t f of t dt, small f of t dt. If capital F of x square is x to the power of 4 plus x to the power of 5, then sigma r is equal to 1 to 12, small f of r square is equal to. It's a simple question. Now, we have the given function whose domain is open interval 0 to infinity, whose codomain is the set of real numbers. Capital F of x is defined as integral 0 to x t times f of t, small f of t dt. Right. Now, f of x is equal to integral 0 to x t times f of t, differentiate with respect to x, then capital F of, the derivative of capital F of x, f prime x, is equal to, when you differentiate, this will be x, small f of x. Call it as equation 1. Given f of x square is equal to x to the power of 4 plus x to the power of 5. Put x square is equal to t. Then capital F of t will be x to the power of 4 is t square plus x to the power of 5 is t to the power of 5 by 2. So capital F of t, we got it, right? So f prime t, capital F prime t is 2t plus 5 by 2, t to the power of 3 by 2. Call it as the equation 2. So from equation 1 and 2, from equation 1, you can also write f prime, capital F prime t is t times f of t. So from 1 and 2, we'll get t times f of t is equal to 2t plus 5 by 2 into t to the power of 3 by 2. What is that all we are doing? We want to get small f of t. Right, f of t is equal to 2 plus 5 by 2 t to the power of 1 by 2. We want 5 f of r square. So substitute for t r square, f of r square is equal to 2 plus 5 by 2 r square to the power of 1 by 2 is r. Right. Now take the sigma. We want sigma r is equal to 1 to 12, small f of r square is equal to sigma r is equal to 1 to 12, and f of r square is 2 plus 5 by 2 r. That is, separate them, sigma of 2 plus 5 by 2 into sigma of r. Sigma r is equal to 1 to 12 of 2. 2 is to be added 12 times, that is 2 into 12 plus 5 by 2 into sigma r is r into r plus 1 by 2, where r takes the value 12. That will be 12 into 12 plus 1 by 2. So simplify, 2 12s are 24 plus 5 by 2 into 12 into 12 plus 1 by 2, that is 12 into 13 by 2. Simplify, you will get 24 into 195, and when added, you will get the answer 219. The answer to this question is 219, and that is the detailed discussion of the solution of this problem. Right. We have now come to the end of this video, and in this we have taken the 6 questions under the numerical value questions from the examinations, JEE Main examinations that are held in the first session on the topic definite integrals. I am sure that you have understood the solutions of these problems. I make a request that you please like and share my videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.